Hello everyone, in this video we are going to solve part B of question number 10. In this again you are given a quadrilateral where AB, which is this AB, is given parallel to EG and this is parallel to DC, and E is the midpoint of AD. Then you have to prove that G is also the midpoint of BC. And again you have to prove that twice of EG is equals to AB plus CD. This part is same as the first part, which is part A of question number 10, and to prove these we'll follow the same procedure. First of all, we'll consider this triangle which is ABD, and if E is the midpoint, and according to midpoint theorem these two lines are parallel, and if we draw a parallel line from the midpoint of any side, so it should meet the midpoint of the third side. So F should be the midpoint. And similarly, in triangle this DBC one. So if this is parallel line and this is the midpoint, which we have proved in this triangle ABD, and this is midpoint, and if we are drawing a parallel line, this should again meet the midpoint of the third side. So that is how we can prove that G is the midpoint. Now let's prove that in triangle. First of all, A, B, D. In triangle ABD, EF is parallel to AB and E is the midpoint. So according to midpoint theorem, if we draw a parallel line, from a midpoint to the second side, so it should be the midpoint of the third side. So F is also a midpoint. F should also be a midpoint. Again, this is because midpoint theorem. Now if F is the midpoint, now in triangle this is DBC. In triangle DBC we have proved F is the midpoint of this DB, and this is given parallel to U, and if I draw a parallel line from the midpoint, again it should meet the midpoint of the third side. So F is the midpoint of side. This is DB. And in triangle DBC, F is the midpoint, and this is FG is parallel to DC. This is given to you. So G is the midpoint of side CB. Again, this is because of midpoint theorem. So this is how we can prove that G is the midpoint of side BC. Now let's prove this. To prove this, again I have to consider this first part which says F is the midpoint. So if E and F are the midpoint, and if I join these midpoints, so clearly this line must be half of this AB. So I can write it as EF must be equals to half of AB. This is because of midpoint theorem. Similarly, in triangle this DBC, I have already proved that F and G are the midpoints, and if I join this midpoints, so clearly this line must be half of this third line. So again I can write it as FG must be equals to half of DC. This is again because of midpoint theorem. And if I add these two equations, if I consider this as 1 and this as second equation, and adding equation first and second, we can conclude that EF plus FG must be equals to half of AB plus half of DC. So EF plus FG can be written as EG. So this can be written as EG. And if I take half as common, so AB plus DC will remain inside the bracket. And if I cross multiply it, this 2 will multiply with EG, and here AB plus DC will remain inside the bracket. So this is what we have to prove, that twice of EG is equals to AB plus CD. So this is how you can solve this second part. Okay, now if you are able to prove this, so using this as a formula, we can solve the third part, which is the C part of question number 10th. Thank you.